So prime factorization, these are going to be some guided notes rather than the notes on a notebook paper. So we have the list of the 10 prime numbers, and 1 is not a prime number because it has to be divisible by 1 and itself. And the word "and" means two different situations that have to file, but it's not the same thing. So if it's two different, it's not the same. What is a prime factorization? It is the multiplication of all the smallest prime factors that make up a number. There are two methods we can use to find the prime factorization number. For example, there's the factor tree, and that's what you've been doing for a long time. And we're going to find the prime factorization of 24 in a couple of different ways. You don't have to like it. 24. So we're going to do it one way. What's one of the factors of 24, Chris? 4 and 6. Okay. So we're going to go, let's try 2 and 12 first. Or, more importantly, so let's do 2 and 12. That's going to be 2 times 2 times 6. So that prime factorization, when it comes out, is 2 times 2 times 2 times 3. And if you do it correct, it should come out to be a product of 24. This is what's happening with that, Aiden. Do you agree that 2 times 12 is 24? Do you agree that 2 times 2 times 6 is 24? These two are factors of 12. Remember how I talk about how you need time to process? Let your brain think about it before your mouth asks what's going on. You keep going until all the numbers on the bottom are prime. Stephen?
So you can use 3 and 4?
3 and 4?
Yeah. In the beginning? Wait, no, back to 6. No, back. For 12. No, go back. No, for 12. Wait, 3 and 4.
Oh, yeah, sure, definitely. Yeah, you know what?
See, it changes too much.
It doesn't change too much. Watch.
I know, but there's way too many.
Just watch. 3 and 4, 2 and 3. You put them in order, and look, I didn't have to change this bottom one. Mm-hmm. Raise your hand. Yes.
So can you use 1?
Use 1? Well, this, yeah, anything times 1 is still 1.
Can you use 1 for 2?
1 for 2.
1 in the place of 2.
No. 1 times anything is the same as anything. Now we're going to go 3 times 8. Okay, so that's going to be 2 and 4. So 2 is here, 2 is here, 2 is here. And once again, we put them in order, 2 times 2 times 2 times 3. And it's going to be, I could see that if I were to turn around rather than shouting out saying I have a question. We have when I'm speaking. Two times 2 times 3 is the same as we just had over here. 2 times 2 times 3. Now, there's another way of doing this. Yes? 6 and 4. So I'll go 6 and 4. So we have 2 times 3 times 2 times 2. So once again, I'm going to put them in order. And I'm going to look at all these next to each other now. And if I can get out that far. 50. There we go. So looking at all these next to each other, it says here, why did the third try work faster? Why did the third one work faster? Marion? Good. We used composite numbers. We used composite numbers. Yeah.
So both numbers have to be composite.
To save time, you want to use it because on the one on the left here, we use 2, which is a prime number. On the middle, we use 3, which is a prime number. No matter what, you're going to get the right answer. However, it's faster if you use composite numbers first. Yes, sir? Yes. Now we have the ladder method. Okay, that's the ladder method. This was used with greatest common factor, least common multiple, possibly, that sort of thing. So ladder method 2, in the book this is called the cake method because it's done from the bottom up, and this is actually, as I've learned from one of my students, this is the way they always teach division in Columbia. The city where one of my students is from, one of my students.
Wait, Columbia.
Find the country. Sorry, Columbia, Brazil. I meant Brazil.
In Brazil?
Find the prime factorization of 36. Start trying off with different factor pairs. So this is the upside down. So I'm going to do, we have 12. You want to use 12? Yeah. So 3 and 12. 3, so we got 12. 3 and 4. So what I'm doing is I'm doing this number divided by that becomes this. It's upside down division. It's also known as upside down division. Get out of here. Then we have, then we have a factor of 4, which would be 2, and then that would just leave 2 down here. When I'm done with my, when I'm done is when I have a prime number down here. Okay? When I'm done, when I have it as a prime number down there. So now I'm going to take all the numbers that are on the outside, I guess I could have just, there. All the numbers that are on the outside, I'm going to multiply those together. So I have 2 times 2 times 3 times 3. 4 times 3 is 12. Times 3 is 36. So when I multiply those all together, I should have my original number. And if I do, I know that I did it correctly. Yes, ma'am?
So what if in your first step you did 6?
What if my first step it is 6? Okay, let's do that. Go over to this one.
18.
Okay? We have 6 here, and we're going to get 6 there. Then we have 6 here, but it's going to be 1. That could work. Also, we could do 2 and get 3. We can do 3 and get 2.
So you're dividing what's on the outside.
It's upside down division. That's the ladder method. So
But 6 isn't prime, so it's not prime factorization.
we have 2, 3, and 6. You are... Now look at this. Why did the third try not work? Because 6 is composite. Now we're going to do a different one here. I'm going to do 2, which would be 18, 2, which would be 9. I get 3 and 3. In a different method, I still get 2 times 2 times 3 times 3. And this one doesn't work because this guy here isn't prime. Because 6 is composite. Salud. What time do we get out of this class? Ooh, okay, we got to hurry up.
How do you do it with a negative?
I bet you'll find out.
Oh, yeah, I will.
So with 18, this is what you do first. The very first thing you do is you get out that -1, because as it says to the left on the chalkboard here, A negative number is -1 times a positive number. So I get that out of here. Now I have 18. I'm going to put this -1 over here right away. 18, we have, I'm going to do composite numbers if I can, which would be, can I do composite numbers, but 2 of them? Think of the factors of 18. No, we can't. So now I have them all done, so I'm going to do 2 times 3 times 3, and that's how you get -18. You first take the negative number out.
Could you do that with the ladder method?
With the ladder method, it would be this.
I just want to make sure I did it right. I did it with that. I thought one was in negative. I thought this was prime.
You have to make -1. -1.
How is that not one?
You can divide -1 by -1 and 1.
What if we use
It's just
negative?
confusing.
What if we use -9? Oh my god.
A -9,
Yeah.
that would come out to need to put the negative out as well.
So what? No, not on the left, on the treatment. Instead of using -1. Can we use -9?
Then this -1 would come out later, but it has to come out. The reason why the prime factorization, you have all those that get multiplied together to get your original number. In order to have that, you have to have a negative within your prime factorization. So I have a -1 taking this out. I have a 38. x to the 4th. Then I'm going to have 38 right here. And we just did this last night.
Were you dividing by x to the fourth? If you do that with the ladder method, design like that one.
38. What are my factors that I can do 38 that if they're multiple composites? We could do 2 times 19, but can we do 4 times? No. Two times 19. So now I'm going to do -1, 2, 19, which is prime, x, 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 x. Yep. Multiply those all together, we have -38 x to the 4th. Amel? Yes, because you don't know what they are, but you have to have them all represented. They're always going to go at the end, and the negative will always go in front. Cole? Yeah. You can use whatever you want on the homework. Yes, you do have homework, and I need to assign it in the next 2 minutes. Do we need to do another negative because we already did one? Okay, good. Do we need to do this one? Okay. So I'll do the ladder method on this one. I will not do the ladder method on this one.
What are you guys saying? I get puzzled. No, I'm not always puzzled.
You know that breaks down into looking like that from the exponent stuff that we did yesterday?
Wait, Mrs. Smith. Good question, by the way.
Yeah. 9 and 5? Oh. Yeah. Yeah, because 9 factors out to 3, 3. So you're still going to have 3, 3. Aiden?
Did you just write the variables down at the bottom, or you just get rid of them?
Yep. Yeah, the way that I taught my pre-algebra class was this. Don't put that away because I got to tell you what your homework is so you can write it on there. So we still got 50 seconds, 50 seconds. What I did for this, listen, this might help some of you. What I did for my pre-algebra class was this. I say vacation. I put those guys on a vacation, and then I just brought them back in at the end. Here's your homework. They see you trolling. Page 187, 14 through 40, and 42.